So in order to make safe and unbreakable locks, we have to use post-quantum safe cryptography. So a bunch of terms are out there. PQC is a very common term. And for that reason, we have today Aditya. He joined us. He's been researching on it, and he's got a lot of great information to share. I think you will all enjoy what he has put together today. Aditya, to you.
Thank you. Just give me a second. Okay, here. Hello, everyone. I hope you all are doing well. So I think at this point, everybody knows about post-quantum cryptography. But still, if there is someone who don't have much about post-quantum cryptography, then this is the slide for you. So before talking about why post-quantum cryptography, we need to answer the simple question, why even cryptography? Sorry, this will be very basic for you guys. Just for the people who doesn't know much about PQC and cryptography, this slide is for them. So let us suppose there are two people, Alice and Bob. So they are sitting on the opposite side of this planet. Now, Alice wants to send a message to Bob through the internet, and Bob receives it. Now, in this message, it was just a hi Bob message, nothing that important. So this is the ideal world where they thought like everyone is good, everyone trusts each other, but practical life is not that easy, right? So this is where a very, very bad guy appeared. For example, in this case, Shankar. So Shankar, since this is not plain text, it is not secure. So Shankar can already see all the messages, and not even Shankar. It's not his fault because the message was already sent in plain text. So due to which Alice and Bob cried for a bit. Then they thought, what could be the solution of it? So they came up with the idea, let's use cryptography, classical cryptography specifically. So when classical cryptography is there, so Alice has a public key, she locks this message or she encrypts this message, and this becomes a ciphertext. So it's not plain text anymore. And only Bob can unlock or decrypt this message using his private key. So at this point, the message which was plain text is now ciphertext, which means apart from Alice and Bob, nobody else can see this message, not even Shankar. So this is the time where Shankar became emotional. And by the way, these are the tears of joy and happiness. These are the tears of defeat and hatred. And at this point, Shankar said, I will take revenge. So after a few years, everything was going fine. The Alice and Bob said everything is encrypted format, everything is fine. But the good thing and the bad thing about Shankar is he never forgets to take revenge. So that's why now he has turned evil. Let's throw the horns as well. And this time he brought a quantum computer. And it's not just a random quantum computer, it's very, very powerful computer. It's that much powerful computer that the ciphertext is now decrypted and the original message, hi Bob, is once again is in plain text, which is not secure. So I suppose you already know the script. Alice and Bob tried again. And this time they came up with another idea because it's not always about the problem, it's about the solution. So they came up with the idea, let's use something strong. And this is where they said, let's use post-quantum cryptography. Inside which now Alice has a post-quantum public key, Bob has a post-quantum private key. She logs and encrypts the message. Once again, it's not plain text anymore, and it's in ciphertext format. And Shankar became emotional again. And finally, he realized the fact that he lost and can't do much anything about it. But it's fine because now he's trying to become a good person. So all is well if it ends well. So this is the case why we need post-quantum cryptography, but still there are some people who says why I am even presenting this. Because what we need is a very powerful quantum computer or cryptographically relevant quantum computer. Since it's not there and it will take years, why are we even discussing this? And I understand their point of view, but the problem is not when quantum computers will be there. The problem is something else, and that problem is store now, decrypt later. So for example, this is your collected data, bunch of data, which is being collected somewhere in the world. They are collecting it, and it's a fact. Okay, so you're not doing anything about it because you're saying this is encrypted data. What will people take benefit out of it? It's encrypted format. These are your transactional mails. These are your financial information. These are defense-related information. Some are really long-term information which needs to be encrypted. But let us suppose in future, in near future, a quantum computer is available. So these encrypted data that you thought was safe, but these were actually encrypted using classical cryptography. So which quantum computers can break? So now at this point, all the data will be decrypted, which were encrypted using classical cryptography. So what can we do? But at the same point, there's your data again. And what I could suggest is you can do is adopt PQC today. So after the point you adopt PQC, all the data after that will be protected no matter at what time quantum computer is available. This will be protected. And I'm really sorry, and unfortunately, we can't do much with the data that is already lost. But better suggestion is adopt PQC as soon as possible. And this is store now decrypt later or harvest now decrypt later. And there is a even bigger problem than this. That is procrastination. Even delaying the fact that you need to migrate PQC at some later time, at some point of interval, it's not a good idea, because as soon as you will migrate to PQC, the more data will be saved and protected. So this is what even industry realized. That is where the US government in December 22 started this Quantum Computing Cybersecurity Preparedness Act, where he asked the management to migrate to PQC as soon as within the year NIST standardized their new algorithms. And that is where NIST last year standardized 3 new algorithms, and they also provided new specifications. For example, in which it was mentioned like these algorithms, elliptic curve, Diffie-Hellman, and RSA, will be deprecated within 5 years and will be completely disallowed in 10 years. And trust me, 10 years in crypto world is just nothing. And by the way, these elliptic curve and RSA, these are the base of internet. Everything is encrypted and saved using this. So you can imagine how vast the security breaches can be. And other organizations like GSMA, IBM, Vodafone, they established post-quantum telco network task force, which uh, which documented this guideline, post-quantum cryptography for telecom use cases. It helps with the 5G core migration and PQC for RAN purposes and UU purposes. And OpenSSL this year they released OpenSSL 3.5, and you know that OpenSSL is such a widely used SSL and TLS library. This included MLK, MLDS, SLS, DSA, which means they have also started migrating to PQC. And LF did not lag behind. Last year they launched Post Quantum Cryptographic Alliance under Linux Foundation, and it's personally my favorite because the vice chair of PQCA Tech is a really great guy. So here's a short bio, which I didn't introduce myself in the initial. Hey, it's me, Aditya Gurunga. That's me right there. And I'm the vice chair of PQCA Tech. Apart from that, I am the tech for small businesses at OpenSSL Foundation, similarly for OpenSSL Corporation. And I'm the maintainer and contributor at Ngkore community, which I am representing today. And I'm also the chief security architect at Quora Labs. Anyways, so you might have heard about the Sol Typhoon espionages, which have already affected like 9 telecom big companies. This was even using the classical computer. No, I think quantum computers are not yet involved in these attacks, but you can see even with classical computers, the attacks are so vast. What will be the impact of quantum computers? What will the impact? How many more security breaches there will be there? For example, there could be some attacks like quantum incremental attack. There could be quantum powered MC catchers, and there are some token hijacking, and there are some like generic attacks also, which can be possible using the classical computer. It is, but the impact will be much higher when there is quantum computer. So I've also included them as well: robustation and unknown network function injection. So these are the basic attacks. There could be much more. It will take, I think, days if we talk about all those attacks. But I think at this point, we have all realized the problem, what the problem is. Now let's take a look at the solution. So there are security standards, for example, NIST, they have uh, passed this FIPS 203, 204, 205. These are the PQC standardized algorithms that need to be adopted by the industry. This year also HQC was also added on this. Similarly, there are some specification like transition to post-quantum cryptography by NIST, which helps us in the migrations things and transition things. And one more important thing is IETF RFCs. These are based on PQC1, all the RFCs that I mentioned, and there are many more. These are the basis of internet. So these need to be added and implemented within your infrastructure and projects and deployment as well. GSM PQTN framework is there, good for telco purposes, and Mitophyte framework is also there. And somewhere these some of the standards are already implemented in these open source project library pools. For example, OpenSSL, LibOQS, PQCP, LibOQS, and PQCP are under PQCA. And You can also accelerate these PQC algorithms using some tools like CuPQC. And for other purposes, whatever your use case and whatever will be a good fit, you can use these libraries, and you can directly implement and directly apply these projects over this open source as well as closed source projects, your approach. So what we did, like we started with Ether. Ether, we have already implemented PQC, and Magma will do, I think. And similarly for OSC, you can do OSC in some part we have tried, and OEI we have done. These are the projects. So this is very generic statement, generic projects. But if you want to look at something specific to LF, what LF is doing in this field, then LF have these projects, libocase, Ocaspride, and PQ code package. These are under a PQCA. These can be directly implemented with LFC and LFN projects, and these are the standards. And let's take these all the learnings and let's try to implement it in an example. So example is of classical 5G core. You already know about the classical architecture 5G core. Interfaces, bunch of net functions. But what I want is your focus to be here on the left-hand side. These are the protocols. For example, MTLS representing the red lines over there. This is not secure against quantum attacks. And these protocols and algorithms are standardized by 3GPP. So ECC for UDM, for ECI's purpose, it's all not quantum safe. IPSec not quantum safe. AS128 is completely fine, nothing against quantum attacks. Over 2.8, it uses RSA, it's not quantum safe. Similarly, DTLS IPSec by default, it's not quantum safe. So what we need is a planning, a complete solid migration strategy, a roadmap. So this is where we prepare this migration strategy. You can see for the classical mechanism, they are upgraded to post-quantum mechanisms. MTLS for service-based interfaces. Now we'll use PQ-MTLS 1.3, which is, when I say PQ-MTLS 1.3, it's MTLS 1.3 with PQ support. Okay, it's not a new algorithm or protocol, just MTLS 1.3 with PQ support. I just want to highlight the PQ part because TLS 1.3 can run without PQ. We all know that. So it's PQ with MTLS 1.3, which many projects are doing right now. Classical signature scheme that will be migrated with MLDSA, IPSec, post-quantum IKV2, IKV2 with post-quantum support. There are a bunch of RFCs for that. DTLS now will be using DTLS 1.3 post-quantum. And for external interfaces, N3 and 4, similar IKV2, we need to be there. And ECI is very specific to the concealment of an identifier. For that, now we were using, currently in 3GPP, it says elliptic curve cryptography, but we will have to use MLCAM or hybrid MLCAM. Similarly, for the authorization part, we have OAuth 2.0. Everybody knows this. It will be using PQ OAuth 2.0, which will be using MLDSA. And you might observe the last two rows are somewhat blurred because these are not mandatory or specific things. It is just a suggestion that in order to improve your security, you can also migrate to AES 256. Nothing against quantum attacks, although people have like mixed opinion on this. Some supports AES 128, for example, NIST, and NCSC and Australian government as a government, they say AES 256 should be there, but it's fine, I think. And similarly, for random numbers, you can use QRNG and TRNG just to improve more randomness. This is what we did. So just mentioned in the slide. Now, this is all knowledge that we gathered, but knowledge is not only about knowing, it's about applying. So after applying these strategies, what we got is a post-quantum core. So you can see the base architecture is still the same. All we have done is change the protocol. So earlier MTLS was there, now PQ-MTLS is there, MLCAM is there, PQ-IPSec is there in place of IPSec, which means PQ-MTLS is quantum safe. For UDM, we were using ECIS, elliptic curve cryptography. Now MLCAM, it's quantum safe. And for randomness, just the thing that we did, QRNG or TRNG, otherwise it's also fine. AS256, it's up to you whether you want to try this or not. For authorization, what we need is post-quantum tokens. So post-quantum authorization based is there. PQ-IPSec and PQ-DTLS is there. So let us take all these things one by one and see which one can be done first, which can be done second. So this is a post-quantum service-based interface. It's PQ-MTLS 1.3. We all know that every network function communicates to NRF. They do the registration and then they send the encrypted packet. So PQ-MTLS 1.3 does the same. And when we zoom in on the PQ-MTLS 1.3 part, this is what we got. So you can see here the protocols here. Now it says signature scheme is MLDSA, and similarly we can go with the hybrid mode because not everyone is some people want the complete PQC, and the best approach we can see is hybrid PQC, which means classical cryptography as well as PQC, so that it doesn't be a something completely new. All the some part of it should be a familiar one, right? And for key exchange mechanism, we have MLCAM and hybrid MLCAM, and these are all the bunch of additional information that we have. So this is the screenshots of the terminal of the logs of the 5G code that we are using. So you can see in this was while at the registration of NRF, it says MLCAM in the supported curves. Similarly, we have a hybrid approach also. In the PCAP, it says Kyber and X2519. It's an old screenshot. And for certificates, we have MLDSA. And as I said, you can go with the hybrid approach as well. So this was post-quantum MTLS, which is, I think, you should do at the first, and then you can do the migration step by step, one step at a time, right? And then we have PQ-IES. This is PQ post-quantum SUPI concealment, right? SUPI is very important for telco guys. SUPI is very important. That is where it was currently using ECIS. Now what we have done is migrate that ECIS the elliptical part with MLCAM and hybrid MLCAM. So this is the flow. It's a complicated one. And that's why we added new profile C and profile D. So you guys might have read this 3GPP standards, which says profile A, there are two profiles, profile A and profile B for encrypting the SUPI. Although there is one more null scheme, but it doesn't make any sense. So we have introduced this idea of profile C and profile D, where you can use MLCAM for profile C, and you can do profile D with hybrid MLCAM, and the flow will remain the same. Correct? And this is post-quantum IPSec. This is IKEv2 with post-quantum support. So you know which interfaces uses IPSec, right? Now let's zoom in on the PQ-IPSec part. So this is what we did in order to achieve PQ-IPSec. So there are two components. It can be anything, not specific to telco only, right? For example, in this case, if I'm talking about this slide, for example, there is AMF, there is OCU, right? They are external interfaces and two interfaces there. So 3GPP says to use IPSec. So, but we need is a post-quantum IPsec. So, Strong Swan has already introduced post-quantum cryptographic algorithms. This is where we can do hybrid PQ key exchanges, multiple. I think the RFC for this is 9370. I don't specifically remember the RFC number, but there are a bunch of. So, using these multiple hybrid PQ exchanges, you can do a post-quantum tunnel between this. I think I saw one of the demo or video from Cisco. They were using total 5 post-quantum key exchanges while doing the post-quantum IPsec. And this is the PQ part. And in order to improve the performance, what you can do is use eBPF XCP program. So all the XFRM policy upload and IKv2 policies can be offloaded at the XTP using eBPF. This is also can be helpful for monitoring and analysis, right? Along with the performance. And now we have post-quantum zero trust architecture. Zero trust architecture, we have added the PQ part. So the slogan and the mantra has now been modified by us. So when we talk about PQ zero trust architecture, we says every component whether inside or outside your network should not be trusted by default, and it should be considered potentially dangerous. And in future, it might even be using quantum computing. So we have added this quantum computing part. So similarly, you have changed the flow according to that. Now registration is done using PQ-MTLS. Now for authorization, what we have is SCP and NRF. You know this SCP model C and model D. See, it do a service request, it generates token. But now what you will do is generate a post-quantum token. This JWT token are by default RSA and elliptic curve based. Now we will use MLD as a signature for this. So in response, it gets service response, and similarly, services are being taken place after we have generating this post-quantum token. Similarly, you can go with Model D and Model C as well. This is post-quantum zero trust architecture. So core part is done. This is also one, so all the knowledge and learnings can be applied to the ORAN as well, because the protocols and all the protocols algorithms are somewhere are same all the places, right? So this is what we came with the idea of quantum secure ORAN. The thing is, idea is same, multiple interfaces, but the ORAN is like multiple interfaces. The good thing is it provides multiple interfaces so that we can have more integration, interoperability, and more openness. But it also like welcomes some extra security threats. That's why all the interfaces need to be secure, and these are classical at this moment. Now they need to be updated with these post-quantum ones. And we also presented quantum secure ORAN at last month at ORAN Working Group 11. So they were also happy. This was done for the PQC working group, which was introduced, I think, this year in 2025. This is the idea of quantum secure ORAN, and this is not telco specific, guys. It can be the roadmap, the protocols, it can be implemented everywhere. So what were our initiatives? Everyone can have a different approach, but we were working on telco and PQC from the last 5 years. So there were two different teams, right? Telco and PQC. So telecom guys, we are completely open source based. So we manually did in-depth code source reading for multiple open source projects. For example, we did it for Magma, we did it for OEI, we did it for Aether and Free 5GC, and then we compared all of them on the basis of performance, stability, interoperability, and most importantly, security. So we are now well aware which security interfaces should be there, which protocols should be there, and we use some tools. This fuzzing tools were there just to see the vulnerabilities, and we use fake base stations, and we have support from 3GPP, right? Technical specifications are all open. Everyone can read this. And the good thing about this 33.501 specification is every time you read this, you discover something new. It's always the same, always the case for me. And PQC, we were doing a separate thing like implementing PQC. We studied, analyzed multiple PQC libraries, tested benchmarking, and then we explored other things like QRNG and PQC. But the problem was telco guys didn't knew anything about PQC, and PQC guy didn't know about telecom. So what we did, like we had like some discussion togetherly, because the result of cryptography is at least applying it somewhere, right? So we applied it on our telco security interfaces, protocols, wherever it was needed, and that was the basis of post-quantum telecom network. It was the foundation of post-quantum core and post-quantum ORAN, whatever it is. And call for action. I think this is the final slide. So what I can say, there are a bunch of things that you can do, but initially what you can do is align your software, your projects or deployment with NIST PQC standards. Okay. And wherever using OpenSSL, please upgrade it to release 3.5, because it now provides PQC also, and no TLS 1.2 anymore. This is very generic. Only TLS 1.3, because PQC can be integrated on that only. And for keeping up with the latest advancements in PQC, please join our community, Post Quantum Cryptographic Alliance. There are 3 working groups: OQS, PQCP, and tooling. OQS and PQCP, Post Quantum Code Package. We compared it with OpenSSL also, and it was, I think, 10 times or 20 times faster for the PQC algorithm. So we have good implementation. It is under Linux Foundation also. And working group is also there for tooling. That is for CBOM. So CBOM stuff is really important. And finally, save yourself from cryptocrastination. This is procrastination of migration. And the final statement is migration to PQC is not optional, it's must. And this is a post-quantumized bias from my side. Any questions and answers are welcome.
Yes, I would just kind of add, there's not a whole lot to do. If you take the very first step, document and record the APIs and cryptographic use in your project. And I see that some of the folks who are not usual attendees on ONAP, they came from different organizations. So take that message back, that first thing in any threat response is observe. And that observation part is look at your own code, your own application and use cases and APIs. Record the APIs that are already using it, or don't go back to the clear text, and record those too. Maybe you have to add some code. But the code that already exists, where you're already using cryptographic functions to secure your API, record those, and then figure out between your current development, user stories, sprints, and program increments, how you're going to tackle that, because it's much easier when you're touching those modules to update those modules. But you also have to take a holistic approach to see that you are going to remain interoperable. So doing a pre-planning now, taking a step, and the very first step is know what the lay of the land is, right? Some of you may not have been around when original code was written. So it might be jogging your memory exercise for a bit. But let's start with that. There has been a lot of attention paid to it. As Aditya mentioned, GSMA has got a grip on the PQC. They're really concerned about it. Or an alliance where Group 11 is working on it. So there's a lot of attention around. But we are the builders. We're building these capabilities for all of these standards. And if we drop the ball, we're to blame. So I want to make sure that everybody walks away with at least one action item. Keep in mind when you're looking or reading and reviewing the code or actually implementing the code, start recording. Maybe run, create a Jira ticket against your project, Jenkins ticket, whatever you use, to record these, right? In next 2 to 3 months, you will have code reviews and you will have updated. I wish we had a CBOM tool that can go read the code. Uh, there are some tools available, prohibitively expensive at the moment because everybody is concerned and they're paying high prices for those kind of capabilities. But we're doing some research in ONAP with Ericsson and some other folks helping. We're going to come up with something that we can use for all the language, all the repos, at least for ONAP. But any guests who came from other organizations, please do the same. And let's join our efforts together so we can share the knowledge. If we have a good inventory of APIs and where the cryptographic functions are, I think our PTL community is strong enough to build those user story in next releases. And before we know it, we'll have these updated. And I appreciate your time for listening to our story. I think it's relevant and it will also help us maintain that credibility that open source community brings best and the brightest people together and offer the latest, greatest capabilities. We're always ahead of standards organization. Some of these 3GPP or an alliance and GSMA may have not mandated it, but we can build and be proactive about the threat that might come in our future, or SDOs may make it mandatory at some point. Last note to offer, biggest market in the North America. U.S. government is a consumer of a lot of open source software. They have mandated through executive order that in past January 1st, 2027, any new product or services that use cryptographic functions sold to U.S. government entities in DoD and IC must comply with PQC. And that has a rippling effect, right? So that's going to have other governmental organizations use the same language, same standard for RFPs. If that goes, I think that will also spread to NATO and alliance countries. And a lot of the countries who look at these big brothers, they're just going to copy and paste. So very soon between 2027, I don't think it will take 2035 to implement. I think there will be business requirement that your new offering must comply with PQC. So we want to make sure that our foundation and our sphere of influence is not caught in that thing where we build a capability, we're ready to go launch and release, and 2027 brings us some hurdles and bumps. So that's all I have to say. Thank you very much for your time and attention. Back to you.
Thank you. Thank you, Mudasar and Adita. Yeah. So I
Yes.
think they're very the insightful presentation. And from ONF side, we have a small stepping stone supporting the MTLS 1.3. So we moved to 1.2 to 1.3 thanks to SECOM and also Andres. So already moved it. Then we are waiting for next step could be when post quantum is available. We are considering, but we are at there. So it's good for that. And also food chain security is very smart, was smart. And also Adita, your post-quantum network, combination, one side from telecom network and one side from PQC. We need to combine it for secure 5G and coming 6G. It's very insightful. Thank you so much.
Thank you.
Any question for Modesta and Adita?
You mentioned, so this is Andreas here. So you mentioned, of course, that we have the MTLS 1.3 as a minimum, but we are, of course, relying, of course, on, so this is for our internal, let's say, communication between the microservices, and we are relying, of course, on service mesh here and on Istio especially. So which needs then basically to support or to give support for that, because we are not implementing the encryption on the microservice level, but we are relying on the service mesh. So that means we are depending then on the support of the service mesh provider, basically. Yeah. So I think more interesting will be then the external communication, of course, then towards then the network itself and towards then external systems.
Yes, I think for service mesh it's so possible. For example, I think Istio or some projects, it uses cert manager at the end, right? And as I remember, cert manager somewhere uses OpenSL or it's Go crypto library. And in both the cases, we can provide PQ easily. So it's easy to implement this. But I think for service mesh, it encrypts from service points to service point, right? Within the application where it's gone from container interface to the service interface, it is unencrypted.
It is unencrypted. That's right.
Yes. So that also we need to cover in order to be end-to-end.
Oh, really? That's going okay. Currently, service mesh app to the sidecar that is not not encrypted, and then we rely on the for now service sidecar to sidecar encryption with the MTLS. Yes, and then I think we have to add up some more security. The reason since we use a service mesh, it was relatively easier for Andreas moving from 1.2 to 1.3, because otherwise every project in ONAP they have to move on individually. But this is a good point. But as Andrew mentioned, that we needed some support from the service mesh, and as you said, this some is possible. So it sounds good to me.
And on addition to that, just one point. I think I'm taking much time. It's PQC security should be at every level, right? For example, infrastructure level. This is what even Ericsson says, that for infrastructure level, this is firmware signing. You need to do firmware signing with whether you do with the stateless hash-based or XMS, LMS, and then go to the code level, then go to the application, then Kubernetes, all those levels. So it should be end-to-end, step by step, zero trust architecture.
Yes, I agree.
It's just kind of a cap that that traditional view of cybersecurity is that somebody is outside your organization and is intended to steal or hurt your business interests. That's no longer true, right? The majority of the stuff happens as an insider, right? So it's not that somebody had change of heart. Their password, their credential, their token got stolen. So that one event turns an outsider insider. And if you still don't have protected stuff, all of these things, data collection, discoveries, impacts, denial of service, all of these things are possible, right? So when we think of security, I think in the API world or in general risk management schema, we should no longer distinguish between who's outsider, who's insider. I think in the previous presentation from Tech Mahindra, these guys were talking about all these different access controls mechanisms, right? This all points back to we want to make sure who's allowed to do a certain job at a minimum level is allowed to do so. It's a library, a function, an API, or an individual, but no more or no less, right? And then have a context around it, as we were talking about the policy development. What is the context when they are allowed to do it and when they're not allowed to do it, right? If we do our job right on those aspects, then we can tackle both insider and outsider. Otherwise, an outsider could become in some like Leon Panetta move, touch the URL, and all of a sudden your password is hacked, and Hillary Clinton lost her election because of that little move. There are a lot of consequences and a lot of ways to become insider from outsider.
Okay, one question. We are considering ambient mesh. Currently, we are using Sidecar and for protection between the component-to-component communication. But when we move to ambient in the future, which supporting separately L4 and L7, so in that case, post-quantum the cryptography, do you think that they can support that area for ambient mesh?
Yes, I think it can.
It should. You know, you think
Yeah.
about the entire EBF and EBF managers work on the same principles, right? We just have to. That's why I wanted to make it very simple. Just think about it. Where is communication happening, and do you have business justification to protect it? The current mechanisms are always cryptographic mechanism, and if you're already using it, record it, inventory it, because we're going to come revisit and update that, right? It's very simple, right? The first step is very simple. I think the next step may require a little bit of resource allocation, user story, etc. But the first step is easy, and it could become just normal business activities.
Okay, thank you. So Modesta, dear, if you can upload your presentation slide deck to the ONAP DTF Day 2025, the wiki page, it will be great.
Sure.
And then AJ can wrap up. Okay, thank you. If you can stop
Okay,
sharing, I
okay.
can share my screen.
Yes. Just last thing, I want to
Okay.
give a shout out to my colleague who helped me with this PPT, Lakshya Chopra. So thank you to him.
Sure.
Thank you to him. It's not in the meeting today. So thank you.
Okay.
I'll stop sharing.
Thank you. Thank you.